In today's video, we are just going to discuss about NoSQL and MongoDB and more related concepts regarding these two topics. So, without any delay, let's get into the channel. If you are new to our channel, please subscribe our channel and press the bell icon. So first, what is NoSQL? NoSQL is a type of database management system that is designed to handle and store large volumes of unstructured and semi-structured data. As you all know, there are three types of data: structured, unstructured, and semi-structured. Unlike traditional relational databases that uses tables with predefined schemas to store data, NoSQL databases uses flexible data models that can adapt to changes in data structures and are capable of scaling horizontally to handle growing amounts of data. Generally, the term NoSQL originally referred to as non-SQL or non-relational databases, but the term was since evolved to mean not only SQL, as NoSQL databases have expanded to include a wide range of different database architectures and data models. So let's see the real life example of NoSQL. Netflix. You may all have known Netflix is one of the most famous streaming platforms in the world. So, Netflix uses NoSQL databases to store and manage massive amounts of data, including customer profiles, viewing histories, and content recommendations. NoSQL databases allows Netflix to handle large volumes of data and provide fast, reliable access to data across a distributed network. So, not only the Netflix has been discussed here, but also other applications like Uber. If you see the Uber uses NoSQL databases to handle the massive amounts of data generated by its ride-sharing platform, including driver and rider profiles, trip histories, and real-time location data. NoSQL databases provide the scalability and flexibility needed to handle high traffic volumes and changing data models. But also the Airbnb. Airbnb. Airbnb uses NoSQL databases to store and manage data for its booking platform, including property listings, guest profiles, and booking histories. NoSQL databases allow Airbnb to handle large volumes of data, unstructured data, and provide fast, reliable access to data across a distributed network. So, in this way, you can see a lot of applications were using this NoSQL in real life example. So, NoSQL versus SQL. Let's see what's the difference. At high level, SQL databases are general purpose, whereas NoSQL databases are engineered for specific use cases. The primary differences between NoSQL and SQL can be summed up in the following five categories like API, data model, schema requirement, scalability, and data integrity. Each deploys a different approach to these aspects of data storage and retrieval. First of all, API. API is nothing but application programming interface. For NoSQL, SQL is not required as an API to the data in the database. Although many of NoSQL databases offer as SQL-like query language, for SQL databases, SQL is typically the only or predominant interface to the data. And data model. So data model with the NoSQL database systems, data is not modeled as tables with the fixed rows and columns as with SQL DBMS. Instead, depending on the NoSQL database, data can be modeled as JSON documents, graphs with nodes and edges or key value pairs. White column stores uses the table with and row concept, but columns can be dynamic from row to row within a table. Schema. The next scheme, the next thing, yeah. The schema for a NoSQL database is a flexible, meaning there is no fixed structure to the data types, and length for the data elements. Data can be stored in a free form or a schemaless manner. This approach offers programmers a higher degree of flexibility, which can ease development efforts. With SQL, the schema is fixed. Sorry, with SQL databases, the schema is fixed with rigid data types and length for each column, and every row must watch the defined column layout and structure. For example, if a column is defined as an integer, not only the integer type can be stored. And then the next topic is scalability, which means in the SQL and NoSQL main topic. Yeah. Scalability. NoSQL databases usually implement horizontal scaling, also known as scaling out. Scaling out involves adding more hardware to the system, usually in the form of a new commodity servers. Horizontal partitioning is using the sharding to break up large databases into smaller pieces. Spread across multiple servers is frequently used in NoSQL systems. The SQL approach typically is vertical scaling, also referred to as scaling up. With vertical scaling, additional resources are added, such as more powerful CPU or additional memory to handle additional workload or to improve performance. Next thing is data integrity. So, data integrity. NoSQL and SQL databases uses different approaches to protect the integrity of data as it is created, read, updated, and deleted by applications and users. Most NoSQL databases systems manage data integrity with an approach known as BASE, which stands for basically available soft state with eventual consistency. Yeah, using base data may be inconsistent for a period of time, but database replication eventually updates all copies of the data to be consistent. Some applications can tolerate this type of inconsistent data, whereas others cannot. And then the approach used by SQL databases is aforementioned ACID. Each of its four qualities, atomicity, consistency, isolation, and durability, contribute to the contribute to the ability of a transaction to ensure data integrity. Using ACID, each transaction when executed alone in a consistent database state will either complete, producing correct results, or terminate with no effect. In either case, the resulting conditions of the database always will be a consistent state. So generally, we may all have a doubt when to choose a NoSQL database. So let's clear that. With businesses and organizations needing to innovate rapidly, being able to stay agile and continue operating at any scale is the name of the game. NoSQL databases offer flexible schemas and also support a variety of data models that are ideal for building applications that require large data volumes and low latency or response times, for example, online gaming and e commerce web applications. So, let's discuss the types. There are four popular types of NoSQL database systems. Each uses a different type of data model, resulting in a significant differences between each NoSQL type. The first type is document database. Generally, these databases store data as a semi-structured documents such as JSON or XML and can be queried using document-oriented query languages. And it also called as document stores. These databases store semi-structured data as we discussed in the above and descriptions of the data in a document format. They enable developers to create and update programs without needing to reference master schema. Use of document databases has increased along with the use of JavaScript and the JavaScript object notation, that is nothing but JSON, a data interchange format that has gained wide currency among web application developers. Document databases are used for content management and mobile application data handling, such as blogging platforms, web analytics, and e-commerce applications. Couchbase Server, CoachDB, and then MarkLogic, and then MongoDB are examples of document database. So our next type is key value stores. These database stores data as a key value pass and are optimized for simple and fast read or write operation, also known as the key value databases. These systems implement a simple data model that passes a unique key with an associated value. Because this model is simple, it can be used to develop high scalable and performant applications. Key value databases are ideal for session management and catching in web applications such as those needed when managing shopping cart details for online buyers or for managing session details for multiplayer gaming. Implementations differ in the way they are oriented to work with RAM, solid state drives, or disk drives. Examples of popular key value databases include Aerospike, DynamoDB, Redis, and React. So let's get into the next type. Column family stores. These databases stores data as a column families, which are sets of columns that are treated as a single entity. They are optimized for fast and efficient querying of large amounts of data. So our next type is graph database. So graph data stores organize data as a nodes which are similar to rows in a relational databases and edges which represent connections between nodes. Because the graph system stores the relationship between the nodes, it can support richer representations of data relationships. Also, unlike relational database that rely on strict schemas, the graph data model can evolve over time and use. Graph databases are applied in systems that must map relationships such as social media platforms, reservation system, or customer relationship management. Examples of graph databases include Allegro Graph, IBM Graph, and Neo4j. So let's discuss advantages and disadvantages. Advantages and disadvantages. The living things and non-living things. We need to have the advantages and disadvantages. Likewise, we are just going to discuss here the advantages and disadvantages of NoSQL. So first of all, advantages. The first advantage is flexible data model. NoSQL databases are highly flexible as they can store and combine any type of data, both structured, unstructured, unlike relational database that can store in a structured way only. It means that the relational databases stores only the structured way in a structured data, but NoSQL stores both structured and unstructured data, which is been an advantage over here. So the next advantage is evolving data model. NoSQL databases allows you to dynamically update the schema to evolve with changing requirements while ensuring that it would cause no interruption to or downtime to your application. So next is elastic scalability. NoSQL databases can scale to accommodate any type of data growth while maintaining low cost. And then high performance. NoSQL databases are built for great performance measured in terms of both throughput, it's a measure of overall performance, and latency. It is the delay between request and actual response. Next is the open source. NoSQL database don't require expensive licensing fees and can run on inexpensive hardware, reducing the deployment and effective. Here, here it's a open source, which is you can easily use without payments. Next is disadvantages. So if there is an advantage, there is also a disadvantage. That it may be anything in the world. So let's discuss the disadvantage of NoSQL. First is lack of standardization. There is no standard that defines rules and roles of NoSQL databases. The design and query languages of NoSQL databases vary widely between NoSQL products, much more widely than they do among traditional SQL database. Next is backup of database. So backup is very important in any databases as you can't easily retrieve your data. So backup of database. Backups are a drawback of in NoSQL database, which is a huge drawback, is it? Though some NoSQL databases like MongoDB provide some tools for backup, these tools are not mature enough to ensure proper complete data backup. And then the final thing is consistency. NoSQL puts a scalability and performance first, but when it comes to consistency of the data, NoSQL doesn't take much consideration, so it makes a little insecure as compared to the relational database. Example in NoSQL databases, if you enter the same set of data again, it will take it out without any issuing any error, whereas relational database ensure that no duplicate rows get entry in databases. And then applications that utilizes NoSQL. As we already discussed, NoSQL has been used in many of the applications in our real time. So they are Uber, Forbes, Netflix, Airbnb, and then much more things. So next topic is applications of NoSQL. So that's mean the applications ideal for NoSQL. NoSQL databases have many use cases, but they were especially ideal in certain circumstances and types of applications. These applications include the following: Internet of Things, real-time or nearly real-time data processing, mobile apps, discussion threads, social media, knowledge base, e-commerce, applications you need to develop quickly, applications that require various forms of data, and systems that processes large amount of data, applications you need to grow and scale rapidly. So let's discuss each thing one by one. So first thing is e-commerce applications. NoSQL databases can help e-commerce companies manage large volumes of data, including product catalogs, customer profiles, and transaction histories. NoSQL databases are also capable of handling high traffic volumes, making them as an excellent choice for e-commerce applications that experience surges in demand. E-commerce E-commerce applications require the ability to manage a large volume of data. including product catalogs, customer profiles, and transaction histories. This data is often unstructured or semi structured, making it challenging to manage with traditional relational databases. NoSQL databases are designed to handle these type of data and provide the necessary scalability and performance to support high traffic e-commerce applications. In an e-commerce application, a NoSQL database can store product data including product descriptions, prices, images, and availability. NoSQL databases can handle large product catalogs with ease, making it easy for customers to search for and find the products as they need. Customer data is another critical component of an e-commerce application because NoSQL databases can store customer profiles including name, addresses, purchase histories, and preferences, and then their mobile numbers. With NoSQL databases, e-commerce companies can build personalized experience for their customers, providing targeted product recommendations and personalized offers based on the purchase history and preferences. And then finally, NoSQL databases can also store transaction histories, providing a complete record of all transactions that have occurred in the e-commerce application. This data can be used for reporting. Yeah. And then social media platforms. So in today's world, there are lots and lots of social medias that we are using in the day-to-day life for everything, for our personal uses and for everything, for chatting, and then for ordering any groceries in the e-commerce websites, and then booking to travel around the world. There are lots and lots. So let's discuss the social media platforms. Social media platforms generate vast amounts of unstructured data in the form of posts, comments, likes, shares, and user profiles. This data is highly variable and unpredictable, making it difficult to manage with relational databases. NoSQL databases, on the other hand, are designed to handle unstructured data and provide the necessary scalability and flexibility to support social media applications. So, if you consider the advantage of the NoSQL, one of the main advantage of NoSQL databases for social media platforms is their ability to store and process unstructured data at a scale. Social media platforms generate an enormous amount of unstructured data every day, and NoSQL databases can handle this data efficiently and effectively. With NoSQL databases, social media platforms can store, post, comments, likes, and shares, and quickly retrieve this data and even when needed. So I may have a mistake. If you consider social medias, we may use Facebook, WhatsApp, Instagram, Twitter, and lots more. That's been renamed as X in today's world, in today's days. Yeah. And next thing is Internet of Things. The Internet of Things is a network of connected devices that generate vast amounts of data from sensors, cameras, and other sources. This data is often unstructured or semi structured, making it difficult to manage with traditional relational databases. NoSQL databases, however, are designed to handle the volume and variety of data generated by IoT devices and offer the flexibility to accommodate evolving data models. One of the primary benefits of NoSQL database for IoT applications for is their ability to handle large volumes of data in real time. IoT devices generate data continuously, and NoSQL databases can store and process this data quickly and efficiently. With NoSQL databases, IoT applications can collect and analyze data from millions and millions of devices in real time, providing valuable insights into user behavior, performance, and maintenance needs. NoSQL databases are also highly scalable, which is essential for IoT applications that may need to accommodate tens of thousands or even millions of devices. As the number of devices and the volume of data grows, NoSQL databases can scale horizontally to accommodate the additional load. This scalability is critical for IoT applications that need to process large amount of data quickly and efficiently to learn. And the next thing and is the final thing before a topic is mobile applications. Mobile applications are an ubiquitous part of modern life with billions of users worldwide generating vast amounts of data. NoSQL databases are well suited to handle the data generated by mobile applications, including user profiles, location data, and app usage statistics. With NoSQL databases, Mobile applications can provide fast, reliable access to data across a distributed network. The advantage of NoSQL databases for mobile applications is their ability to handle semi structured and unstructured data. Mobile applications generate a variety of data, including text, images, video, and NoSQL databases can accommodate this variety of data. This flexibility is crucial and critical for mobile applications that need to store and process data in variety of formats. And then next thing is gaming. So gaming companies generate a massive amount of data from player data to game states, high scores, and more. NoSQL databases are an excellent choice for gaming companies as they can store and manage large volumes of player data with ease. Additionally, NoSQL databases are well suited to handling high traffic volumes, making them an excellent choice for gaming applications that experience surges in demand. A good reason why NoSQL databases are fit for gaming companies is their ability to store and manage large volumes of player data. Gaming companies must maintain a vast amount of player data, including profiles, preferences, progress, and achievements. NoSQL databases can handle this data effectively, allowing gaming companies to access and analyze player data efficiently. And finally, and the final topic is big data analytics. In today's data driven world, big data analytics has become a crucial tool for companies seeking to gain an insights in their operations, customers, and markets. However, the traditional relational databases are often not suited for big data analytics because they struggle to handle large volumes of unstructured data. This is where NoSQL database come in. So this is where it's being used here. Yeah. NoSQL databases are designed to handle large volumes of unstructured data, making them an excellent choice for big data analytics. Whether it's text data, sensor data, or multimedia data, NoSQL databases can handle it all, providing fast and flexible access to data. One of the primary advantages of NoSQL databases for big data analytics is their ability to handle large volumes of data. NoSQL databases can scale horizontally, allowing companies to add more computing power and storage as needed. The scalability means that NoSQL databases can handle even the largest data sets, providing fast and efficient data access. NoSQL databases also offer flexible data models, which is essential for big data analytics. In traditional relational databases, data must be organized into rigid structure, which can be limiting when dealing with unstructured data. NoSQL databases, on the other hand, can handle uh, can handle a variety of data models, including a key value, document, and graph models. This flexibility means that companies can store and analyze data in a way that best suits for their needs. So finally, the final thing of NoSQL is its history. So let's discuss its history. The term NoSQL was used by Carlos Strozzi in 1998 to name his lightweight Strozzi NoSQL. NoSQL open source relational database that did not expose the standard structured query language interface but was still relational. Is NoSQL RDMS is distinct from around 2009 general concept of NoSQL database. So let's get dive into our next topic, that is MongoDB. So first of all, what is MongoDB? MongoDB is built on a scale-out architecture that has become popular with developers for all kinds for developing scalable applications. With evolving data schemas as a document database, MongoDB makes it easier for developers to store structured and unstructured data. It uses a JSON-like format to store the documents, and it's a MongoDB is also a powerful, high scalable, free and open source NoSQL based database. MongoDB was initially released on the 11th Feb 2009 and now it has achieved the position of the leading NoSQL database. MongoDB provides a high scalable database and is currently being used as a backend data store of many well-known organizations like IBM, Twitter, Zendesk, Forbes, Facebook, Google, etc. It also caught the eyes of the open source commodity and have a lot of developers working on various open source projects based on MongoDB. It is fast and reliable database that is one of the recommended database in designing scalable web applications that require the storage of unstructured data. So if you are designing an application when we need high availability, clustering and fast performance, when we must consider using MongoDB as our application backend database. MongoDB is a document-based data store, which means that it stores the information in an unstructured format as compared to structured tables like in MySQL or PostgreSQL. MongoDB. Moreover, the fact that MongoDB has been written in C++ makes it even faster as compared to a lot of other applications. MongoDB should not be used in applications that require table joins simply because it does not support joins like in SQL. And so let's discuss the data types in MongoDB. MongoDB supports many data types. Some of them are string, integer, boolean, double, min or max keys, or arrays. Sorry, unarrays. String. This is the most commonly used data type to store the data. String in MongoDB must be UTF-8 valid. An integer. This type is used to store a numerical value. Integer can be a 32-bit or 64-bit depending on your server. So in boolean, this type is used to store a boolean, that means, as you all may know, true or false values. Double. This type is used to store a floating point values. Min and max keys. This type is used to compare a value against the lowest and highest Bison elements. And then arrays. This type is used to store arrays or list or multiple values into one key. And then let's see the MongoDB advantages and limitations. So if you consider advantages, there are lots and lots. In that we shall see some of them. Yeah, the first thing is the flexible database, sharding, high speed, high availability, scalability, full technical support, ad hoc query support, easy environment setup. And then the limitations, like high memory usage, joins not support, limited data stays, and limited nesting. So let's see the differences between the two things that we were discussing from the beginning. That is nothing but and the thing we are discussing right now. There is nothing but NoSQL and MongoDB. So if you consider the differences between these two, the first thing the first thing is RDBMS. It's a relational database. As the expansion also denotes that it's a relational database management system. So if you consider MongoDB, it's a non-relational database and document-oriented database. And if you can, and RDMS is not suitable for hierarchical data storage, whereas the MongoDB is suitable for hierarchical data storage. It is vertically scalable. That is RDMS. I am saying about the RDMS. And MongoDB, if you consider MongoDB, it's horizontally scalable. We can add more servers. And RDMS has predefined schema, whereas MongoDB has a dynamic schema. It is quite vulnerable to SQL injection, whereas MongoDB it is not affected by SQL injection. So it centers around asset properties. It centers around the CAP, that is consistency, availability, and partition tolerance theorem. It's a row based and it's a document based. It is slower in comparison with MongoDB. It is almost 100 times faster than RDBMS, that is relational database management system. MongoDB is faster than the relational database management system 100 times. So let's see the applications of MongoDB. MongoDB is widely used across various web applications as the primary data store. One of the most popular web development stacks, the main stack, employs MongoDB as the data store. Main stands for MongoDB, ExpressJS, and AngularJS. So, and then our next topic, we shall see the next topic, that is how to download and install MongoDB on Windows. So it's easy steps. Let's see step by step. Step 1. Download the MongoDB MSI installer package. Head over here and download the current version of MongoDB. Make sure you select MSI as the package you want to download. Step 2. Install MongoDB with the installation wizard. Make sure you are logged in as a user with admin privileges. Then navigate to your downloads folder and double click on the .msi package you just downloaded. This will launch the installation wizard. And then click next to start installation. As you all may see here, it's how the screen displays. You have to click the next to start this installation. And the next thing is you have to accept the license agreement, then click next. As you have see, it's been displaying like this here. So it also be it also too displaying in here laptops or PCs. And then select the complete setup, and select run service as network service user and make a note of the data directory we will need to this data. We won't need Mongo Compass, so deselect it and click next, and then click install to begin installation. Hit finish to complete this installation. Hey, you now sorry, now you have successfully installed your MongoDB. Yeah. So the basic operations in MongoDB, that is how to create, insert, update, delete, and drop this database. First of all, create operation. So we may all use this use command here. The MongoDB use database name is to create a database. The command will create a new database if it does not exist. Otherwise, it will return the existing database. So let's see the syntax here. Basic syntax of use database statement is as follows. So use database name. You may have different names in your mind. Yeah. Example: if you want to use a database with small name MyDB, then use database statement would be as follows. As you all may see here. Yeah. Next operation is insert operation. The insert operation is used to insert the data into the database. To insert the data into the data MongoDB collection, you need to use MongoDB insert or save method. Syntax. The basic syntax of insert command is as follows: db.collection_name.insert of document. So you may have see the example here. Next is the update operation. MongoDB update method. The update method updates the values in existing data. So there are a lot of methods that is built in within this update method. So the basic syntax of the update method is as follows: db.collection_date collection_name dot update of selection criteria updated data, as the example where there. Yeah. And then drop operation. So it is used to drop any data in the data or a database. Yeah, sorry. So show dbs, it will display the currently existing databases. Yeah. If you want to delete a new database, then drop database of command would be as follows.